Hi friends, we are in chapter 4, section 3, and we're looking at relations. For the most part, when we're talking about relations, particularly as it relates to Algebra 1, we're going to be talking about a relationship between two numbers. So like your ordered pairs. So you might have 4 and 3, 2 and -1, 0 and 7, and these are ordered pairs and they are representing a relation. So the set of ordered pairs or the set of these associations would represent a relation. So how I can show this relation is in a particular way as ordered pairs, but I can also show it as a mapping. So I could have one group of numbers here. These are my x values, and these are my y values, and I just chose to write them in a different order. In fact, I'm going to write the x values from 0, 2, and 4 just in increasing order. And now what I can do is show a mapping where I'm associating 4 with 3 because that is a part of the relation that I want to demonstrate. And forgot this was a -1, 2 with -1, and then 0 with 7. So what we've seen demonstrated is a mapping. It's a way of representing a relation. And one thing that we can do, we should talk about this if we haven't. This would be the domain, and this part would be the range. The x values generally refer to the domain, and the y values refer to the range. One thing that I can do is show the inverse of this particular relation. So the inverse would be switching the x and y. So how I would do that as ordered pairs, the inverse would be written as 3, 4, -1, 2, and 7, 0. So this would be inverse, the inverse relation of the relation we have here. And of course I can do an inverse mapping where the domain and range switch places. So now the range is -1. So now the domain rather is -1, 3, and 7. And the domain and the range, I'm getting this confused guys, is 0, 2, and 4. Okay, and again, the relationship would happen as I wrap 3 with 4, -1 with 2, and 7 with 0. So let's get back to the idea of representation here. And what we see is that we can represent relations as ordered pairs, as tables, we represent them in graphs, and we represent them in mapping. So here we are at example 1. We're going to express this current relation as a table, a graph, and a mapping. And you guys get the idea already, I'm pretty sure. To represent it as a table, we need an x column and a y column. And basically what we're going to do is just write all the x values down. And here are those x values. And then what I'll do is I'll put the associated y values right next to it. And there's my table, and then graphing, you know, we're putting the ordered pairs on a coordinate plane. And here's a representative graph where each of those points are located on the XY axis. And finally, a mapping. And finally, our mapping, which we're going to do just as we've done in the past, where we associate each member of the domain with its corresponding member in the range. So each x value with the corresponding y value. And there we go. I think I got that wrong. Let me see. This 3 goes to, +3 goes to 2. There we go. All right, so this is our representation. Determine the domain. I'm not going to write this over again. The domain is this group here, and the range is this group here. Let's look at another example. Here we're basically using this information about a bald eagle survey done from 1993 to the year 2000 and the number of eagles seen. And we can see that there's been a sharp increase over time. And we're going to determine the domain and the range. The domain is usually the x values. The domain generally refers to the independent variable, if you remember us using that language before. And so the domain is the thing that doesn't that is happening regardless of the other one. It's independent. And so generally time is independent. So determine the domain and range. The domain here would be the years. So the domain is the set of all of those years, and the range is therefore the set of the number of eagles sighted in this particular area. So With that in mind, the next part is to graph the data. As you can see, I cheated and I left the graph here, but notice that on the x-axis is where we put the independent or the domain, and the range, it goes along the y-axis. But what I also want you to recognize is that we had to be specific about how to fit all this information here. Notice on the y-axis, we start at 0, but we go up increments of 50 in order to accommodate the data. And that's something that you want to make sure you do at another time when you are working on, your graphs. You want to make sure and accommodate the data that's given. And also, we didn't start at year 0. We started at maybe 1992 to make that like the beginning year, even though our first bit of information was the first year that they showed, 1993, and we had that information. So this is typical of making sure that we can see all of the data in our graph. So earlier we defined the idea of a relation as the switching, as the inverse, as the switching of the coordinates in a relation. So the inverse relation would be here. That's not new. But what we didn't discuss is what that looks like when we graph it. Notice the relationship between these points. When you graph the relation, when you have this relation and the actual original function graphed, what you'll notice is that they are symmetric. Those points are symmetric about what we would call this red line is called the y equals x line. And we can talk about that at a later time when we start graphing linear equations a little more. But check this out. Notice that what's on one side has its, in a sense, cousin on the other side. And that's one of the significant representations of a relation and its inverse. With that in mind, just an idea of what your assignment's going to look like. You're going to be expressing each relation as a table, a mapping, and then talking about what the domain and range is. This is all stuff that I think you're really comfortable with. You're going to express a relation in different ways. Once you see it in one way, you're going to be able to represent it in different ways. And this is typically just getting comfortable with the idea of domain, range, x, y, tables, graphings, mappings, and so forth and so on. If you have any questions, let me know. It has been a pleasure. I look forward to seeing you soon. Bye-bye.